In this video, we'll look at how to apply stoichiometry conversions. Stoichiometry is how we can relate definite proportions of matter to one another. Usually this takes the form of comparing amounts of reactants and/or products from a balanced chemical equation. Here, we will look at how to apply stoichiometry within a molecule. For example, consider a molecule of water, H2O. We can count the atoms that make up this molecule. There are 2 hydrogens and 1 oxygen in every 1 molecule of water. We can write this information as a conversion factor having the form 1 molecule of water over 2 atoms of hydrogen, or 2 atoms of hydrogen over 1 molecule of water. Like all conversion factors, the specific arrangement depends on the given information in the problem and what it is you're trying to solve. The other way we can set up a stoichiometry conversion is to scale up 1 molecule to 1 mole. I'll show you how it works here, but it won't be necessary for you to do this particular conversion every time. So we can start with 1 molecule of water over 2 atoms of hydrogen. We can then apply Avogadro's number. So we have molecules of water in the denominator and mole of water in the numerator. So it's 1 mole of water to 6.022 times 10 to the 23 molecules of water. Notice then that molecules of water will cancel. We can then apply a similar scaling to the atoms of hydrogen, where now we need the atoms of hydrogen that are already in the denominator to cancel with new atoms of hydrogen in this numerator. So atoms of hydrogen go in the numerator, and mole of hydrogen goes in the denominator. So the numbers are 1 mole of hydrogen and 6.022 times 10 to the 23 atoms of hydrogen. We can now cancel atoms of hydrogen. Even though they're not next to each other, we still have a numerator and a denominator. And we can cancel the 6.022 times 10 to the 23 because that also appears in a numerator and a denominator. So we end up with the same values as the molecules to atoms conversion. 1 mole of water over 2 moles of hydrogen. So let's work through an example by looking at vitamin C. A medium orange contains 3.97 times 10 to the negative 4 moles of vitamin C, which has a chemical formula C6H8O6. How many moles of oxygen are in this vitamin C? So we'll start with what we're given, which is 3.97 times 10 to the negative 4 moles of C6H8O6. When we set up our stoichiometry conversion factor, we need to make sure that the denominator units in the conversion factor cancel with the original units. So that means that moles of C6H8O6 will go in the denominator, and moles of atoms, in this case moles of oxygen, will go in the numerator. If we look at the chemical formula of vitamin C, we can see that there are 6 oxygens. So the numerator would be 6 moles of oxygen compared to 1 mole of vitamin C. So we'll make sure that our units cancel, and then we'll check our sig figs. Our given value has 3 sig figs. Both parts of stoichiometry are exact, so we will ignore them, ignore these values for sig figs. So our final answer will have 3 sig figs. So when we do the math, 3.97 times 10 to the negative 4 times 6, we get 2.38 times 10 to the negative 3. Units are moles. Substance is oxygen.